Hello, our goal in this video is to learn how to compute the volume of a solid of revolution. In fact, we are asked to compute the volume of the solid obtained by the rotation of the region bounded by the curves y equals x square, minus 3x and y equals 0 around the x-axis, for all x in the closed interval from 0 to 2. When we have this type of question, it is crucial to have a graph of the region. This will allow us to learn more about the geometry of the problem, and adopt the proper method to solve it. In this case, the region is bounded by the curve x square, minus 3x and the x-axis. The axis of rotation is also contained in this region. This is important because it will allow us to use the disk method to compute the volume of the solid. This is the graph of the resulting solid. In order to compute the volume of this solid, we will use the disk method. As we can see from this graph, the axis of rotation is also contained in this solid. The shaded region on the following graph corresponds to the region that will be rotated around the x-axis to obtain the solid. It is clear that, for any x in the interval from 0 to 2, the radius of the disk is given by the absolute value of the function f of x. This is the distance from the axis of rotation to the curve y equals x square, minus 3x. The cross-section area of the disk is given by the formula a of x, which equals pi times the square of the radius. In this case, the radius is the absolute value of f of x, which is the absolute value of x square, minus 3x. The volume is given by the integral of the cross-section area from 0 to 2. This is the integral from 0 to 2 of pi times x square, minus 3x, squared. The volume is pi times the integral from 0 to 2 of x to the power 4, minus 3x cubed, minus 3x cubed, plus 9x squared dx. Using the fact that the integral of x to the power 4, minus 3x cubed, minus 3x cubed, plus 9x squared is 48x to the power 5, minus 360x to the power 4, plus 720x cubed over 240. So the volume of the solid is obtained by evaluating the antiderivative from 0 to 2. Evaluating the antiderivative from 0 to 2 of pi times 48x to the power 5 minus 360x to the power 4, plus 720x cubed over 240 gives us the volume of the solid, which is pi times 32 over 5. Therefore, the volume of the solid is pi times 32 over 5.